Welcome back. It is time for the Oh Wow moment brought to you by the Gloria and Roger Jones Children's Center for Science and Technology. And I've got my girl Elainie here this morning, and we're going to do something exciting, no question about it. And I saw glasses, Elainie, yes. So that means that we're going to have to exercise care of taking care of our eyes and be safe, right?
Absolutely. Safety
okay.
First, and I got these red ones that match your outfit.
Red for the Halloween, not Halloween, Valentine's Day and me. Okay. Yes. Elainie, what are we doing today?
So we are doing a chemistry experiment. It is popularized as the whoosh bottle experiment because you use a bottle and it makes a whoosh.
Whoa!
It has to do with combustion and chemicals. So the first one we're going to do is this small bottle over here. And
okay.
Like I said, combustion, you know what that is, right?
No. Fire. Tell our viewers and tell me. Fire!
So we are definitely going to want to stay back a little bit from this one. So this is 91% isopropyl alcohol. And alcohol is very, very flammable.
Okay.
And it is also very volatile, which just means that it evaporates very easily, especially at room temperature.
All right. Turning on your microphone.
Fill up this bottle.
Wait.
Oops.
I'm supposed to be doing this on the slide. Wait. There we go. Okay. All right.
All right. So I am just coating the inside of this bottle with 91% isopropyl alcohol.
Okay.
And this is just like what you find in your house. You could get this at the same stuff you would get at a pharmacy. But don't try this at home. It is very flammable, and you'll see that in a minute. So if you're ever using this around a flame, do be very careful.
Are we going to light it on fire?
We are going to make some fire. I'm going to pour out the excess here. So what I've just done is coated the inside of this bottle.
Okay.
And it's evaporating because, like I said, alcohol is very volatile.
Okay.
So this is now full of the vapor. And what I'm going to do is I'm just going to hold the flame over this, and it's going to make a whoosh. I want you to pay attention to the sound that it makes, because as you can see, we have different size bottles. So we're going to do
I'm
this
stepping
again
back
here.
now. Sis.
And just watch what happens. I have another lighter if this one doesn't. There we go. And
it sounded like a whistle.
Yeah, it whooshed or whistled. And if you notice, it kind of whistled at the end. It went like back and forth.
Yeah.
That oscillation is because when you light the vapor, it heats up and expands, and the air rushes out. That's what makes the whoosh.
And it came out the little hole on the top. Okay.
But then it condenses, it cools down, and comes back in. But it doesn't stabilize right away, so you kind of get that whistle effect at the end.
Oh,
let's
really do cool. A bigger one.
Yes, so we're going to do the bigger one. And with the bigger one, like I said...
Set the station on fire! No.
Yeah, I don't know where the fire extinguisher is. No, we're okay. Little fires. So... and once the alcohol burns up, it's all gone. So there's no other fuel for it.
I'm too excited about this.
But yeah, so with this one, I want you to pay attention because I'm going to put this on really quickly. Like I said, that compression happens with the gases inside.
Be stepping back. Okay.
So you'll actually see that. I'll show you here.
Oh, Elainie. Let me make sure. Okay. Fire extinguisher. Okay.
Just
make sure I know where the fire extinguisher is.
Oh, we'll be okay.
I love it. Yeah, I could just imagine my boss, Madonna, I can't believe you set the station on fire.
Hey, it would be my fault.
Yeah, I did, sir, and it was fun.
Are you ready?
I'm ready. No, okay, let me step back a little. Okay, now I'm ready. Wow.
And then...
What's going to happen?
So see how
it's shrinking.
Yeah, it's squeezing together. So that's from the atmospheric pressure. So when the gas inside the bottle is compressing, it's actually becoming more dense than the air on the outside, and the atmosphere is pushing down, so it crushes the bottle.
I see. Wait, and when I heard it pop, you see I jumped like, okay, can only jump so far.
And you'll also notice there's some water in here.
Where did that water come from?
So that water came from, combustion is a chemical reaction. That's what I meant when I said this is a chemistry experiment.
Okay.
So combustion happens because of a chemical reaction that is activated by the heat from the flame between the alcohol and then Do you know what fuels fire?
Yes.
It's a gas, oxygen.
Yes.
Yes. So the oxygen reacts with the alcohol, which has hydrogen in it. And if you know the chemical formula for water, do you know it?
H2O.
H2O, yes. So the hydrogen is the H, the oxygen is the O, and that's how you get the H2O as a product of this. And then also carbon dioxide, just like any other flame.
2 hydrogens, 1 oxygen. All right, let's do the bigger bottle.
All right, this is the last one. And with this one, last week we talked
got about
about
a minute left, Tim
Newton's
says.
laws. All right. So last week we talked about Newton's laws. We
Yes,
can
we
demonstrate Newton's laws with this one as well. I'm actually going to lay this one on its side, and
Okay.
it's going to get propelled across the table with the flame. So I'm going to put it right here. So the flame won't, can we see that? Yes, we can see that. Great.
Okay.
The flame will not touch you. If anything,
Okay.
it'll be
Make
on this
it
side.
go, Elainie. Make
All
it
right.
shoot off the table.
There we go. Oh, it only went a little bit. That's okay.
Oh, wait. I thought it was going to go more.
Yeah,
but...
I tested this on our
right.
table, and
Okay.
and it went across the table, but this must be a little stickier.
That's okay. That's okay. Well, Elainie, you're so awesome. You're awesome.
Oh, thank you.
Thank you for showing us this chemical reaction. And we're going to take a break. And when we come back, we're going to have Reuben Robinson singing us some Valentine music. We will be right back.